Now, I can't picture that number of dollars in my mind, but it's a huge amount of money. We all know that oil and gas is big business. If you look globally, 5 to 6 million wells have been drilled for oil and gas. Now, this is a huge amount of wells, and because of that, it's a huge amount of learning. And something that the oil and gas business is good at, is something I've kind of highlighted here, is that we have always striven to make things more efficient, to reduce waste, to make things bigger, better, faster, and of course safer. And the reason that we've been able to do that is because we come from a business that is heavily funded and is expensive. So by making things faster and more efficient, we save a lot of money. If we draw the comparison to geothermal energy, it's worth somewhere in the region of $5 billion a year. Not quite the 4 trillion that oil and gas is worth. Geothermal energy still suffers from the expense related to drilling wells, and it's a risky business. There are fewer than 10,000 geothermal wells in the world. These numbers are a stark comparison to oil and gas. And based on these numbers, you can begin to understand why geothermal energy doesn't have the money and the expertise to do some of the things and develop the technologies that oil and gas has. And the simple conclusion is that the oil and gas business can teach geothermal energy a huge amount. So if we have a look at the energy mix, global consumption, 74%-ish comes from fossil fuels, coal, gas, and oil. There's a massive focus for us to move away from fossil fuels, and that is being done. COP26 was over the last few weeks, and there are all kinds of promises that we will move away from initially coal and then oil and gas. But geothermal appears down at the very bottom of the list at 0.3%. It depends which statistics you use. It may be as high as 0.5% at the moment, but it's a very small amount. And there are numerous reasons for this. I'll go into those. But I do get this question a lot: why isn't there more geothermal energy? And this is a question which has a historical grounding. So let's just quickly have a look at how geothermal works. This is the traditional perception. 2 wells are drilled. Cold water is pumped down the first well. That hopefully migrates into the area of the second well. It's heated up during that process. It is then brought to surface, converted to steam, drives a turbine, and generates electricity. There's always the perception that it needs to be somewhere very hot, and there's also an underlying perception that it doesn't always work, and that's kind of an important thing to bear in mind. So the problems with geothermal energy. The problems that are associated with geothermal are also the reasons that the business has not thrived as much as people think that perhaps it should. The first one, as I've already mentioned, is that most people think that you need to live on a volcano in Iceland in order to benefit from geothermal energy. Fewer people know that it's also associated with something that I refer to as seismic hooliganism. Now, seismic hooliganism is secondary seismic activity which is generated because of traditional geothermal methods. There is a very famous case in France, actually, up in the north, near Strasbourg, a place called Vendenheim, where Fonroche drilled a series of wells. They started pumping fluids, and they created an earthquake of 2.8 on the Richter scale. That earthquake was created due to the injection of the fluids, either through fault lubrication or pressure and temperature changes. Because of the earthquake, the operation was immediately shut down, and that led to actually a shutdown which still is in place now, some 18 months, 2 years later. So it's a significant thing. And unfortunately for the people in Vendenheim, the earthquakes are still coming. They are increasing in magnitude as well. So it's a very, very serious problem. There's also a perception that wells need to be very deep to generate geothermal energy. It's expensive. Now it is expensive to drill wells. We know that from oil and gas. And the idea of drilling an expensive well, which isn't guaranteed to produce, is something that the risk averse will shy away from. And then there is the risky nature due to uncertainty because of subsurface connectivity. The diagram I showed earlier on of the two wells, those wells don't always connect, and that can be a big problem. You don't know whether the project is going to work until those two wells have been drilled and you're actually in a testing phase. Now that is in stark comparison even to oil and gas, for example. If you drill one oil and gas well, you generally know whether you've made a discovery. So there's that extra element of risk. So I've come up with this brilliant equation, which sits at the bottom of the screen here, that says conventional geothermal is equal to volcanoes, hooliganism, expense, and risk. And because of that, then it hasn't widely been adopted. There are other reasons, but I see these as the main reasons. If we look at how new technologies dispel these undesirable aspects of geothermal, and I'll try and dispel some of those myths. The new technologies being introduced today mean that we can work with modest temperatures to generate electricity. CeraPHi Energy can generate electricity with geothermal gradients as low as 30 degrees Celsius per kilometer. Now, to put that into perspective, this is a geothermal gradient map of the UK. Everywhere that is blue has a geothermal gradient which is less than 30 degrees Celsius. So everywhere that is not blue, we can generate electricity by drilling a relatively modestly depth geothermal well. The areas that are orange and red are obviously more favorable. So to give another context, this is a map of the States. The areas that are dark green basically are not really very useful for geothermal energy. Everything that's yellow and up to purple can be used very happily for geothermal energy and specifically electricity generation. Everywhere on the map can be used to generate heat, and that's something to remember in the back of your mind. The seismic hooliganism is something that is de-risked through closed-loop wells. We don't inject into the subsurface, and we don't require fracking in order to join wells. There are some closed-loop companies who actually do undertake fracking, but CeraPHi is not one of those. We can drill wells that are quite modest as far as the depth is concerned. For example, in the UK, if we're looking at 30 degrees Celsius per kilometre, we only need to drill a 5-kilometre well or less in order to generate electricity. Of course, the deeper you go, the hotter it gets, and the more beneficial it is. But if you do have restrictions, then depth does not have to be a big problem. Compared to other alternative energy sources, wind and solar, then closed-loop systems are competitively priced. Of course, we can't compete with oil and gas for very obvious reasons. The risk, which is generally associated with seismic hooliganism and subsurface connectivity, is therefore dispelled because of the closed-loop system. And because of these new closed-loop geothermal companies, then the 2020s are being referred to as the Geothermal Decade. You may also have noticed that geothermal is much more commonly in the news nowadays. So just to create some perspective of what we use energy for, these numbers here are for the UK. 40 to 50% of household energy is used for heating and cooling, mainly in the UK, of course, for heating. There are also industrial uses for heating and cooling. And the reason I mention this is that it takes somewhere in the region of 5 megawatts of electricity to generate 1 megawatt of heat energy. That is incredibly inefficient. So if you look at industry, for example, heat is used for drying, for cooking, curing, washing, sterilizing, distilling, brewing. There are many, many different uses. So rather than generating electricity, transporting it inefficiently, and then converting it into heating and cooling, the geothermal industry is asking, why not just use the heat beneath our feet? Direct heat use is a very elegant way of using energy. It negates a huge amount of inefficiency. So just to have a look at the obvious, to me, benefits of using geothermal energy. When compared to other alternative energies, the most striking thing is that it is baseload. Offshore wind in the UK has a 40% efficacy. Whereas, of course, once you've drilled a geothermal well, it does have a little bit of downtime for maintenance, but basically it's 24/7, which is a very, very important thing. It's scalable. We can drill relatively modest wells, or we can drill deep wells in multiple numbers and create anything from, let's say, 0.5 megawatt up to hundreds of megawatts in one area. It's off-grid. Now, this is important to some, but not to others. The end of this sentence here, I talk about energy independence, but I've written Remember Texas, and the reason for that is that, I don't know if you guys remember, but earlier on in the year, the end of February, I think it was, there was a massive snowstorm in Texas, which led to infrastructure failure, and that in turn led to loss of life, which is a travesty. But off-grid solutions obviously have very limited infrastructure, and they negate some of those problems. Geothermal energy has a small footprint. If you look at a single geothermal well, we need, of course, a well pad. Let's say that's 100 meters by 100 meters to drill the well. But after that, it can be reduced to 25% of that, unlike some other alternative energies. Being an environmentalist, I don't like to see the world smother with solar panels. Energy security, once you have a geothermal well drilled and producing, international energy prices do not affect what you're doing. The weather doesn't affect what you're doing. So you are protected from those trends. Food security is something I particularly like. Heat generation could be done anywhere. That heat can be used for agricultural purposes, which I particularly like. It reduces food miles, which is very, very important. Again, it's another efficiency which can be introduced. We can grow pineapples in the UK with heat from geothermal energy. And that means that we don't have to ship the pineapples thousands of miles across the planet. It's a very, very positive and efficient solution. Direct heat can be used for heating and cooling for district and community projects. We already have more than 100 of these projects in the UK. Of course, closed loop geothermal has no emissions at all. We require electricity to drive our pumps, but we can actually use solar or our own wind turbines to do that, and associated batteries. No exotic minerals. Because we are literally just drilling wells, we require basic oil and gas technology to do that, and that doesn't involve the mining of rare earths and some of these unsavory images that the National Geographic did an expose on a few years ago. Of course, solar and wind both require these exotic minerals. We estimate that there are 50 jobs created per megawatt of energy created, and these are associated with the geothermal energy in the outtakes. It's not actually the jobs that are required to run 1 megawatt of geothermal energy. Offshoots are also desalination, which is great for island solutions and remote and desert locations, and of course hydrogen generation. Hydrogen is in the news a lot recently, but a great deal of that hydrogen is related to blue hydrogen, which comes from oil and gas production and then carbon sequestration through CCS. Not the most elegant of solutions. And of course, it is an energy anywhere solution. So because of that list, then we receive a great deal of attention from environment, social, and governance managers. We tick a great deal of those boxes. So going back to the equation of geothermal equaling volcanoes, hooliganism, expense, and risk, what is the solution? Now, I suppose I would say this, but it has to be CeraPHi Energy and closed loop, more widely speaking. Oil and gas meets geothermal. What we have done is we've married the two industries, and we have solved the issues related to geothermal because of our knowledge of oil and gas and how energy systems work. So just doing a quick précis here of geothermal energy. On the far left, we have ground source heat pumps. They are a very, very useful solution in small scale. They can be used for individual houses or collections of houses. There are even some very large building collections which use hundreds and hundreds of these in order to generate enough heat energy. In the middle, we have the conventional geothermal solution, where fluid is pumped down one well, hopefully migrates and is harvested by the second. What we refer to as the CeraPHi well requires a single well to be drilled down to what we look for is at least, hopefully, 150 degrees Celsius in order to generate electricity. We then use a heat exchanger and we deliver energy in the form of heat to the surface, which can then be used to drive an organic Rankine cycle to generate electricity, or it can be used for direct heat uses, which I've already touched upon. So let's have a look at the pros and cons. On the left, we have conventional geothermal systems. On the right, we have the CeraPHi well, a closed-loop geothermal solution. You will have noticed that, generally speaking, conventional geothermal systems require deviated wells because in CeraPHi, we are just looking for heat, temperature, then our wells are vertical. As a result, there's a greater measured depth associated with the conventional geothermal solution and lesser in the closed-loop CeraPHi wells. There's a limited subsurface life of geothermal solutions, of the open loop, and this is because of the quite nasty materials that they circulate around their systems. Because in CeraPHi we don't have any exposure to the subsurface, our wells can last many, many decades longer. I've already touched on the high risk of exploration associated with connectivity of wells. That risk is mitigated within the closed loop solutions. There's stimulation or simulation or fracking required in the conventional geothermal solutions because sometimes they're lucky enough to have connectivity when you're talking about hydrothermal systems, but the enhanced geothermal systems do require that fracking and connectivity to be created. As a result of all of this, I think that you can tell that the CeraPHi solution is very, very simple. A vertical solution which is cased and then completed. I've colored this one differently. I've talked about failure and the reasons that conventional geothermal fails. We have an incredibly low exploration risk. The most difficult thing that we need to do in the CeraPHi well is actually drill that well in the first place. As I've already mentioned, we come from oil and gas. More than 5 million wells have been drilled globally. So drilling a well is not a great challenge. So because of that, then risk is almost totally mitigated. But when you look at the failure of geothermal wells, we can actually take those failed geothermal wells and repurpose them with a CeraPHi well completion and make those broken wells work. That is a huge bonus. But then, if you think about the 5 or 6 million oil and gas wells that we have globally, we can also repurpose those. And that is something that is incredibly important. Conventional geothermal, as I've already mentioned, it has a reservoir requirement, whereas that's not something that we require in closed loop solutions. There's also a high running cost, and that running cost is related to environmental management of waste products that come to the surface and the vast amounts of fluid, let's say 400 cubes per hour, that need to be pumped into the subsurface. So that's an expensive business. Whereas the only things that we need to run a a closed loop system are a pump, effectively. The well life of a closed loop, of an open loop conventional system may be 30 years if you're lucky. Closed loop systems will last a lot longer than that because we don't have any contamination from the subsurface. So, in summary, it's a self-contained single loop system. We can create combined heat and power from modest depths anywhere. And of course, this includes sedimentary basins. Generally speaking, the enhanced geothermal systems drill into granites or gneisses or other igneous metamorphic rocks. We can generate energy from small or large scales. We can use heat for direct industrial or domestic uses. And of course, there's that elegant agricultural use as well. And lastly, but by no means least, is the repurposing of oil and gas wells. And let's not forget, because we have no emissions, we have no carbon dioxide at all generated during production through closed loop systems. I'm now going to touch on the repurposing of oil and gas wells, which basically helps towards the decarbonisation of oil and gas. The image here is taken in Texas. You have a couple of oil wells very happily pumping away, let's say 100 barrels a day, something like that. At $82 a barrel, we're doing okay. At some point, these wells will come to an end of their useful life. They then need to be abandoned at some expense. Rather than abandoning these existing wells, we can take them and we can repurpose them with a CeraPHi well solution. It's a simple workover process. And then the energy generated can be used in these nearby buildings, whether they be industrial or domestic, for heating directly. In the outlier occasions, you might also be able to generate electricity. But this is basically turning a liability into an asset. And that is something that is growing in pace and getting a great deal of attention. First of all, as I've already mentioned, the district heating, the industrial uses and the agriculture, but there's also employment that is associated with that. If you look at Texas, there are tens of thousands, maybe even 1 million oil and gas wells that have been drilled there. The oil and gas business is going to slowly slow down over the coming decades, and the employment that's lost in that slowdown can be used in the repurposing of those wells to geothermal producers. Another solution that is offered in CeraPHi, but not necessarily in other geothermal solutions, is what we call the CoPro well, and this is a solution for oil and gas companies who want to decarbonize their production. So we will drill a deep geothermal producer, and we will complete that in the main leg of the well. So this is a geothermal completion. That well is then sidetracked and into an existing oil and gas reservoir. So when it comes to production at the wellhead, we can produce both oil and gas and geothermal energy. The oil and gas goes to the production facility. The geothermal energy goes to a geothermal energy production facility. The electricity from that well helps to decarbonize the oil and gas energy And what we're doing there is effectively decarbonising the production facility. The secondary heat is used for desalination or local agricultural projects. And we then have a look at the production profile. The orange is the oil and gas profile, something that you guys will be familiar with. We get a plateau of production and then a slow decline until the well waters out. The blue is a geothermal production. We have steady production for many, many decades because it's closed loop. The well doesn't suffer any contamination or failure in the downhole system. There is a slight decline. This shows a horizontal line, but there is a slight decline in production, but it's something that we manage very easily. The elegant thing about this solution as well is that when this oil and gas leg of the well passes its useful life, it can be repurposed into a geothermal producer. At this stage, then we can have 2 blue lines producing geothermal energy. And of course, there is the all-important employment related to this solution. So, in summary, if you look at the total closed-loop CeraPHi well offering, we drill single wells or multiple wells into one area. We have a geothermal production that can be used for water treatment, for hydrogen generation, industrial uses, either in the forms of electricity or direct heat, agricultural projects, or district heating solutions. It's something that is growing very rapidly, and as I've already mentioned, it's why the current 2020s are referred to as the geothermal decade. And of course, there is the employment that is related to geothermal energy in so many guises. So going back to my equation of conventional geothermal being equal to volcanoes, hooliganism, expense, and risk, CeraPHi geothermal, or closed-loop geothermal, it's anywhere, it's discrete, it's competitively priced when compared to alternative energy, and it's incredibly low risk. And because of that, then I would go one step further and say that CeraPHi Energy is energy solved. And once more, welcome to the geothermal decade. I'm sure that you're going to see a lot more geothermal over the coming decade and decades to come. And that's me done. I should add here actually that if anybody would like to get in touch, then LinkedIn is a very easy way of doing that, or my email is there.
I want to thank you so much for this really interesting technology and presentation. And I will now let all participants ask their questions. So you can whether raise your hands or just type your question in the chatting room, what I call chatting room. So yeah. Anyway, I have already 3 questions. So is there anyone who wants to ask any question? I can't see hands. Okay. Mr. Gilles Pelleferme, you can ask your question.
Yeah, thank you. Thank you very much for the presentation. Can you hear me?
Yes, very well.
Okay, thank you. So thanks very much. My question is, where are you as a company in terms of prototyping the technology you are presenting today? What is the term where we can have solutions implemented, tested, and yeah.
Okay, no, that's it's a really good question, and of course it's one we are asked often. I should say that our technology is not new, our solution is new. So every part of what we do is proven technology. So for example, the organic Rankine cycle that we use, we can buy off the shelf. The downhole equipment that we use, much of it is just standard oil and gas. We do use, in some cases, we use some rather interesting heat exchangers, which are new, but the technology is not new. Basically, what we're doing is we're using ground source heat pump technology and making it larger. So none of this is new. All of the different aspects, the different nuts and bolts of our solutions already exist. So that's something that needs to be stressed. Because we come from oil and gas, then we strive for efficiency. We have already started doing R&D into the different fluids that we can use in our closed loops solutions. Those will change with time, and we will finesse those. But to answer your question as when our technology is available, today is the answer. I'm not sure if you've seen the recent press releases made by a few of our partners. We're working with a lot of partners. Not all of them want to make press releases. But about 4 or 5 months ago, Third Energy, which is a UK onshore company who was associated with fracking and also gas wells. There's a moratorium on fracking in the UK, and because of that, they have some wells which are available for us to repurpose. So that announcement was made, as I say, 4 or 5 months ago. So we're already working with Third Energy in North Yorkshire in the UK. About 6 weeks ago, a company called iGas, who is the UK's largest onshore oil and gas operator, announced partnership with CeraPHi. During that day, their share price increased by 58%. Their share price closed up 30%. And this isn't because of the business aspect of the money that they're going to make. It's related purely to the sentiment that surrounds geothermal energy. So for us, that was a good day because of the announcement that iGas made. It revalidated our knowledge that geothermal energy is something that the public is really backing. I hope that answers your question.
Yes, thank you, sir.
Okay, I have another participant who would like to ask another question. Mr. Marzena. Oh, okay, this is difficult. You can go on.
Right, that will be Mrs.
Mrs. I'm really sorry.
Hello, Andy. Thank you very much for the presentation. We are connected on LinkedIn. I just noticed there is Mr. Mika who asked a similar question to mine about the costs, the drilling costs for a new well. But we also have big interest in repurposing existing oil and gas wells, because I think that's the cheapest solution. And very practically, I wanted to ask you about the wellbore size required for repurposing.
Yeah, again, it's a good question. Obviously, the larger the better. That's basic physics. But we can and are working with wells with very, very small completions. We prefer not to, but it really does depend on the outtake of the energy. So, for example, the smallest well size that we're working for is 2 7/8. There's always a solution that can be wrapped around the smaller well bores. A lot depends on well architecture, of course, and also the temperatures. They are key. But as you'll be aware, because we don't need to generate electricity, then the repurposing of wells can be very cost effective. You mentioned briefly drilling. Now, drilling, of course, is the most expensive part of geothermal wells. Having a well sitting there that is in a condition to be repurposed is a gift. And it's why we would encourage all oil and gas operators not to abandon their wells. They can use that abandonment cost to repurpose the well into geothermal and create a very long-term asset. So to answer your question in a roundabout way, we can work in very small well bores. They are, of course, less profitable, and sometimes if they are shallow and low temperatures, then they will not be profitable at all. But that's part of our risking process.
Right. Thank you very much. I think that's sufficient from my side.
Thank you so much, Mrs. I'm really sorry. Now I have two questions in the chatting, what I call chatting room. There is Mr. James Mika who asked approximate costs to drill complete CeraPHi geothermal well. So what is the approximate costs to drill and complete a CeraPHi geothermal well?
That's a question we hear a lot, and of course it depends which country you're in. I think that I'm not sure which country the person asking the question is in, but you'll be aware of how much it costs to drill a conventional oil and gas well, for example. We don't need the expensive data acquisition related to drilling. We, of course, focus very much on drilling wells safely. Because we're closed loop and our only target is heat, then we don't have the upfront subsurface basin analysis that's required. We do need enough data in order to drill a well safely. So we need to be able to predict where we're going to meet formations. We need to be able to do modeling which will give us pore pressure information and potentially geomechanical information. But we don't need to do those very, very expensive investigations which you would associate with oil and gas. We've spoken to partners in Middle Asia, for example, where drilling costs are incredibly low, and because of that, then the well cost will be very low, and the CeraPHi solution will be very modestly priced. If you're looking at Europe, of course, or North America, then costs are more elevated. So effectively, if you take an oil and gas well, take away most of the expensive data acquisition and the fancy completions, We don't need very, very convoluted completions. So I'm not going to give you a number because it really is a piece of string question, but I hope that my answer has given you enough information to draw your own conclusions.
Okay, thank you so much. There is another question from Mr. Stephen Allen. First of all, he thanks you so much, and then what he wrote was, with a modest gradient, I guess for drilling tools, etc., you're not needing a whole sheet of high temperature stuff. So, do you see a future where you will be able to repurpose offshore oil and gas wells as well as onshore wells?
I'm sorry, I didn't catch the first part of your question regarding the modest geothermal gradients. Oh, I think I can read the question actually.
Okay.
Yes, yes is the answer to your question there. Because of the modest gradients, as I say, the drilling tools, the fancy drilling tools aren't required. Can I see a time where offshore wells will be repurposed? The simple answer to that is yes. To elaborate a little bit, we are already working on it. Decarbonisation of existing oil and gas assets is something that is, of course, very important to oil and gas operators. We are already working in partnership with more than one operator in the North Sea, and we are looking at the potential of using heat energy in order to provide heat to producing platforms. We are also in talks with companies globally about the integration of a geothermal well in new production facilities. Why not, for example, if you're going to batch drill a large number of wells for production, why not just add a geothermal well to that solution? You can then actually use the geothermal well to power your entire production facility for its life. Of course, offshore it's more expensive, but it's something that can be done onshore at a much more reasonable cost. So yeah, the answer is it's already being done. We are already in talks and they're going very well. Thank you.
Thank you so much for your answers. I have also 3 questions for me, but I don't know if anyone else would like to ask any other question. So I would like to ask you about the impact of the heat loss because it's one well, as I understood, there is a one well and there are 2 like inside wells in the exchanger deep. So what about the heat loss that you have when you have 2 wells like so close to each other, one that is cool and colder than the other one? Is there any heat loss? And the second question is, to what extent this technology can be used
I'm sorry. I did get the first question about the heat loss, which I'll address initially, and I'll ask you to ask your second question afterwards, if you don't mind. I didn't catch that. So you're quite right. There is heat loss in two different dimensions, actually. First of all, there's heat loss from the bottom of the well to the top, and then there is heat loss with time. So I'll address the heat loss in the well first, and this is something. Let's say we have 150 degrees Celsius at the TD of the well. We may only have a temperature on surface of, let's say, 110 or 120 degrees. We will design the well based on the margins and the losses that we anticipate. If we can live with that 40-degree, let's say, heat loss, and we've modeled it, and we think that that is going to be something that is maintainable, then we might just use standard oil and gas equipment. However, if it's marginal and we need to reduce that heat loss, it's something that we can do using various technologies like insulated piping or vacuum seal piping or something like that, because that means that the heat loss is minimized from the bottom of the well to the top. The other question, and that's something that we have a software package called CeraPHi Pro, and we throw the numbers in. We can tweak the well design, and as a result, we can design our wells around those calculated heat losses. Likewise, another output from CeraPHi Pro is the heat loss over time. We work very closely with some incredibly clever people who are helping to build our analytical tools. So our physicists and mathematicians will determine what the heat loss will be in the subsurface over time. And we can determine that heat loss based on the amount of flow that we have in the well, and we can adjust that flow in order to optimize the heat loss with time. To me, as a geologist, it is a black box of magic. But there is some very serious maths and physics that sits underneath this, and the guys that crunch the numbers are doing a great job for us. So we manage heat loss in both of those directions as far as depth is concerned and time.
Okay, thank you so much. I had another question. To what extent can we use this technology in other types of geothermal production? For example, you're using this technology to do cogeneration. Can we use the same technology for generating only heat in this type of geothermal energy? Only generating heat, not necessarily reaching 150 degrees Celsius. Can we use this technology?
Yes.
Okay.
Yeah, absolutely. The simple answer is yes, and those kind of projects, I think, will become more prolific. When people talk about geothermal energy, everyone automatically assumes electricity, and that is going to change. For example, I've mentioned the repurposing of wells. Most of those repurposing projects will just generate heat. There won't be enough in order to create electricity. But we're already in talks with companies who have very, very clever glasshouse solutions, which have films over them which can generate electricity. So you can use the glasshouse itself to generate electricity. You can use a geothermal repurposed well to generate the heat required. Put the two together, and you have a fantastic solution. Now, that is from an existing oil and gas well. However, there's no reason that same solution shouldn't be created somewhere that there isn't an existing well. why not drill a very shallow well, which will give you those same temperatures, and be able to generate electricity for glasshouse projects, or beg your pardon, heat for glasshouse projects, or heat for district heating solutions, or direct industrial use. We're in talks with companies who have leisure facilities. They own leisure complexes. They spend a fortune every month heating swimming pools. And the way they're doing that is they're importing electricity, and they're taking 5 megawatts of electricity to create 1 megawatt of heat. That, to me, as an environmentalist, is a crime. If you drill a very shallow geothermal well, you can generate one megawatt of heat energy directly. And if you look at that over a period of years, that will save the leisure complex company an absolute fortune. For a start, they're ticking that environmental box. They are using 100% clean energy, CO2 free, but they're also saving themselves on the cost of the electricity. So it's something that, if you look at it long term, and of course it's geothermal energy, so drilling a well to, let's say, a kilometer or two has an expense, but if you look at it over a period of years, it is a great environmentally friendly and economic solution. So it's a really good question, so thank you for that.
Thank you so much for your answer. I have two more questions. I have Mr. I guess, Danius Chulaba. If you're raising your hand, so you can speak.
Yes, I would like to thank for presentation at the beginning, and also would like to ask how much working project you already have, and the most interesting part is for me is reusing of wells in depleted oil fields, and if it's not a secret, what is the smallest project, and what is the biggest, and I don't know, in terms of megawatts, or in terms of working wells. Thanks.
Well, for a start, you're welcome. To answer your question regarding size of projects and the number of projects, as I said, we already have 2 which are announced in the UK. We have literally dozens of other projects that we're working on at various stages around the globe. We are a UK-based company, and it just so happens that our first few projects announced are in the UK. But we're talking to companies that own shopping malls. We're talking to a lady who owns a ranch in Colorado. We are talking to leisure facilities, as I've already mentioned. We're talking to a great many oil and gas companies. We're talking to green fund management companies who own different types of industry that they want to use geothermal energy for. The list is endless, and of course we're talking to companies who are starting glasshouse projects and all of those things that you might imagine. We use a business development software package, and we have literally dozens and dozens of projects at various stages. Our first energy production will be during the first quarter of next year, so not very far away. When that happens, then there will be a great deal more interest in CeraPHi Energy, and I hope closed loop geothermal generally, because there's a great deal of discussion and theory at the moment, but there isn't a great deal of production. There are a number of companies who say that they can repurpose wells, as do we, but there are very few who have actually produced energy. So the first projects that we're going to be producing from will be in the UK. They will be multiple megawatt energy production, but we'll also work with, in the future, we'll work with companies who are looking to produce less than a megawatt, for example. It depends on economics of the projects, and of course, because it's geothermal, we have a very stringent economic vetting process. But we will be producing from let's say 0.5 megawatt up to multiple megawatts of energy. We're looking at repurposing geothermal wells. We're looking at fresh wells. We're looking at repurposing oil and gas wells. Repurposing of oil and gas, I'm guessing, is going to be initially somewhere in the region of 70% of our business.
Thank you very much for your answer.
Thank you. There is Mrs. Rania Hamdi who would like also to ask your question. You can go ahead.
Thank you so much for the lecture. It was so interesting. So I have two questions. One regarding the seismic risk. If this new technology can reduce the seismic risk of, because you know the geothermal energy, it's always treated as involved or develop the seismic risk, and also about the cooperation between the geothermal energy and the decarbonization in the oil and gas. I didn't get the point. How geothermal energy can help? It is when we use depleted reservoir, or when we it's have intervention in carbon storage or gas storage.
Okay.
Yeah.
All right. First of all, the seismic hooliganism, as I call it, I didn't say that we reduce the risk of secondary seismic activity. I said we eradicate the risk. Using our system, there's no fracking to start with, and sometimes earthquakes are associated with fracking. But more importantly, we don't inject fluids into the subsurface at all. And that's where the Vendenheim project in northern France really suffered. They reactivated faults, which created significant earthquakes. So we're not reducing the risk, we eradicate that risk. It's complete mitigation. And going on to your question about how we help oil and gas decarbonize their projects, there are a few different ways. There was a question earlier on about offshore geothermal. It's something that we're looking into. In that case, we take an existing well that's obviously been producing oil and gas but is no longer, and we will recomplete that with a CeraPHi well geothermal solution. We will then produce heat at surface, and we will use that heat to heat the oil and gas facility. Now, some production platforms require a huge amount of heat, just to heat their accommodation, for example. And the way they do that is they ship diesel offshore. There's a logistical association with that. So it means that they don't have to use a diesel generator. They don't have to ship the diesel offshore. So they save themselves the money within burning that hydrocarbon. They reduce their hydrocarbon signature by not having to burn the diesel. They save logistical costs and the hydrocarbon signature of those logistics. So that's the most modest potentially is the offshore. If you look at onshore, we're looking at drilling drilling wells within existing oil and gas fields where we can generate electricity from the TD of a well, and that same well can be sidetracked. So the electricity that is drilled from the mother-bore of the well will be used to power the oil and gas company's production facility. That means that, again, they're not using hydrocarbon sources to power their facilities. They're using geothermal energy. That is decarbonization because it means that they're using CO2-free solutions for their energy. Likewise, we can use those same wells for the secondary heat production, which can be used for district heating solutions in the nearby areas, and energy use for industrial, etc. Then there is the other offshore use where we can drill bespoke geothermal energy wells, which can be used for creating electricity directly for oil and gas facilities. So there are a few different ways that we can help.
Thank you so much for your answer. If there is any other questions, you can go ahead and ask your question.
Yes, I have another question. I'm so curious because you said that your innovative way, it's not basing on fracturation. So how you can enhance it, the geothermal reservoir?
The simple answer to that is you can't. And in the way that we design the wells, there's no need to do any of that enhancement, as you call it. It's not necessary. If we're looking at bespoke wells, then we will drill them to a depth where we achieve temperatures that are high enough to be sustained long term. There is absolutely no need to do any secondary fracking or stimulation. We don't require a reservoir of any type. We rely on conduction. And because of that, then there is no enhancement or fracking stimulation required.
Okay,
Okay,
that's
thank
clear.
you so much.
Thank you.
Any other questions? If there is no question, I will thank you all for attending. I will wait a little bit to see if there is anyone who would like to ask any other question. Okay, so I want to thank you all for being here today, for attending, and thank you especially Mr. Wood for accepting our invitation and for this great opportunity to share with us your technology and advancement in the geothermal field. Thank you so much. And thank you to all the students and all the professionals that are here. I hope I see you all next time in another SPE Geothermal maybe conference. Thank you so much.
Thanks for the invitation, Lisa.
You're welcome.